Students, you're welcome to class today. I want to believe we all have a great day. Today we want to start with a new session under variation. Okay, so we are going to be looking at some questions. I've penciled down some questions that we are going to be looking at, and I want to believe that you are going to learn a lot from this class. So before we commence the class, I want you to get your writing materials ready, and also don't forget to inform someone. Let us have a good number of people watching our video here. All right. Okay. So, and if you are new on this platform, I want you to subscribe to this channel so that whenever we are on here, you'll be duly notified. And also, if this class is impactful, don't forget to give a thumb to the class. All right. So now, can we inform our friends? Let's see those that are around for the class. Okay. All right. So once you just join the class, I want you to give the class a thumb. Give the class a thumb. Let us know that you are in the class. Okay. So now let's look at the first question. The first question is under direct variation. Now let's look at the question. Now, if y varies directly as square root of m and y equals to 9, when m is 9, find y when m is 1/7/9. All right, so let's look at it. How do we solve this type of problem? Now, the first thing is to look at what we have there. Y varies directly as square root of m. So we write y varies, this is the symbol for variation, varies directly as square root of m. Okay, so this implies that y equals to k square root of m, where k is a constant. Always remember to declare your constants. All right, now let's plug in the value of y and m. Now in the question we are given that y is 9. So we have 9 equals to k times square root of m. M is also 9. We have 9 here. Okay, so we have 9 equals to k times 3. All right, so here, since we are looking for k, you divide both sides by 3. So we have 9/3 equals to k. All right, so therefore, k equals to 3. So this is the proportionality constant. All right, so now the next thing is to get the connecting formula, though you are not asked to find that, but you need it to solve this problem. So let's get the connecting formula. So look at this. This is what we are writing out. The only thing that will change here is the k, because we have gotten the k to be 3. Okay, now let's plug in the value of k into this equation. So, right, thus y equals to 3 square root of m. Now this is the connecting formula. Now this is the formula that is connecting y and m. Okay, so we can go ahead now and find y when m is 1/7/9. Okay, so we are given m is 1/7/9, and that is the same thing as, let's convert this one to improper fraction. So 9 times 1 plus 7. So that gives you 16/9. Okay, so now let's plug in the value of m into this equation. So we have y equals to 3 square root of one known number 7 over 9. Okay, so and that's the same thing as y equals to 3 times square root of 16 over 9. Okay, so that is y equals to 3 times. Now the square root of 16 is 4. Now when we say square root of a number, so we are asking for the number that you multiply by itself, okay, that will give you what we have inside the root. Now, so if I say square root of 16, what are you going to multiply by itself to get 16? And that's 4. Okay, and the same thing also applies to 9. So we have 3. So here 3 cancel 3. So we have y equals to 4. And that is the answer to this problem. So now, how do we award marks to this question? Suppose this question is given in an exam. So the first thing now here, for substituting correctly, there will be a method mark here. Okay. So and for getting your constant, we have an accuracy mark 1. All right. So now for writing out the connecting formula, so we have a block mark here. That's B1. Okay, so now you are asked to find y when n is one whole number 7 over 9. So for substituting correctly, so we have a method mark 1. And for getting the correct answer, A1. So total marks is what? 1, 2, 3, 4, 5. So we have five marks altogether. Okay, so that is how to solve this type of problem under direct variation. So now let's move down to another type of question under variation. P varies directly as 1/4 of the square of Q, and Q equals to 6 when P is 0.2. Find P when Q equals to 2. All right, so this is another question. All right, so if you are just joining the class and you have not subscribed to this channel, kindly do that. All right, so that is your duty as a student. Okay, so and if you have not given this video a thumb, kindly do that. All right, so let's look at this question. How do we solve this question? Now we have P varies directly as 1/4 of the square root of the square, of Q, and Q is 6 when P is 0.2. Find P when Q is 2. So how do you solve this type of problem? Okay, so now let's come here. Solution. Now P varies directly as 1/4. Varies directly as 1/4. What is 1/4? That is 1 over 4. 1/4. 1/4 of square of Q. Square of Q is the same thing as Q square. Square of Q. So we have this. Okay. So, and this is the same thing as P varies Q square over 4. All right, so when you multiply these together, you know, off is the same thing as multiplication. Okay, so you can write it this way. All right, now you change this to an equation. So that implies that P equals to KQ squared over 4. All right. So K is what? K is a constant. Now let's look at the question and plug in the values of P and Q. Now in the question we are told that Q is 6, P is 0.2. So we have P to be 0.2 equals to K times 6 squared over 4. Okay, so this is the same thing as 1 over 5. 0.2 is the same thing as 1 over 5. Hope you know, because this is the same thing as 2 over 10. 2 over 10 is 1 over 5 equals to K times 6 times 6 is 36 over 4. All right, so we have 1 over 5 equals to K times, now 4 goes here 1, 4 goes here is 9, so times 9. All right, so you can cross multiply now. So we have 5 times K times 9. That gives you what? That gives you 45K equals to 1. 1 times 1. All right, so we have K equals to 1 over 45. So this is the proportionality constant. And then we can plug in that value into this to get the connecting formula. So now we have thus P equals to, now in place of this K, so you can put this. And don't forget, 45 will be at the denominator here. So we have Q squared over 45 times 4. Okay, 45 times 4. And that is the same thing as when you multiply this and this together, that's 180. So I will have it as P equals to Q squared over 180. So it's the same thing. So this is the connecting formula. All right, so let's look at the question. The question asks us to find P when Q is 2. When Q is 2. So let's plug in the value of Q into that connecting formula. Okay, when Q is 2, we have P equals to 2 squared over 180. And then P equals to 4. 2 squared is 4 over 180. All right, so therefore P equals to, now 4 goes here 1, 4 goes here is 45. So that will be what? 1 over 45. So that's going to be the value of P. Okay, so that's the end of the question. I want to believe we all understand that question now. All right, so how do we award marks to this question? Now, the first thing, for substituting correctly, there will be a method mark. 1 for that. For getting your proportionality constants, we have A1. Now, for writing out the connecting formula, we have B1 here. All right. And also, for substituting into the connecting formula, there will be a method mark. Yes. And for getting your answer to be 1 over 45, you have A1. So how many marks altogether? That's going to be 5 marks. That's 5 marks altogether. All right, so I want to believe we all understand that. So because I want us to be on the same page. Okay. All right, so now let us look at another question on the inverse variation. So we are moving down to inverse variation now. So what we just did now is there are questions under direct variation. So now let's move down to inverse variation. X varies inversely as the cube roots of y, and x is 2 when y is 27. Find A, the connecting formula, and B, find x when y is 125. All right, so this is another question. Okay, so I want us to try it. Let's try this and let's see what we're going to have. So in the next 1 minute, I'm going to provide the solution to that problem. So you can try that. So I want to know if you'll be able to get this in a very short time. Okay, so while you are doing it, so if you are joining this platform for the first time, okay, I want you to subscribe to this channel so that you'll be updated whenever we're on here. And also, if you are right here watching and you like this class, don't forget to give a thumb to the class. All right, and always remember to share this video with your friends so that we have good number viewing this video. All right, so how far are you finding the solution easy? Are you finding the question easy? Okay, so let's see, is there anybody that have an answer to the first one? Let's see, anyone? Okay, can we see the question clearly now? Can we all see the question clearly? Okay, let me try and adjust. Can we see the board clearly? Okay, all right. I'm trying to move. So I think we should see the board now fully. Okay, why is it that some people cannot see the full board? Every one of us should be able to see the full board. Some are seeing why some are not seeing. What happened? Yeah. Okay. Okay, I think we should be seeing this full board now. We should see the full board now. I think it's better now. Okay. Okay, so by now we should have finished. By now we should have finished. So after solving this problem, so I want to confirm what you have as your result. Let's see. Let's just oppose our answers together. All right. So if you are not in the class early, so don't worry. Just follow the class. You'll get to understand what we have done. All right. So you can also play back what we have done. All right. So now let's look at this question now. X varies inversely as the cube root of y, and x is 2 when y is 27. Find A, the connecting formula. B, x when y is 125. So how do you solve this problem? Now the first thing is, look at this first statement here. Now x varies inversely as cube root of y. Now I must understand what inverse means. Now if you are given 2, if I say what is inverse of 2, it's going to be 1 over 2. It's just the reciprocal of 2. Now, if you are given x, if I say what is the inverse of x, that is what? 1 over x. And if you are given a over b, I ask what is the reciprocal of a over b? That is going to be what? Or the inverse of a over b, that's b over a. All right, so I want to believe you understand that. So with that, we will not have much problem here. Now let's read the question now. X varies. X varies. This is symbol for variation. X varies inversely as the cube root of y. Now I must know what is cube root of y. Cube root of y is like this. Cube root of y. This is cube root of y. Now the question says x varies inversely. That is the reciprocal of this. What's going to be the reciprocal of this? That is 1 over cube root of y. All right, so that's what we have there. So I want to believe every one of you understand that. Okay, so now from here you can change this variation to equation by introducing the constant. So you have x equals to k over cube root of y. Yes, do we understand that? So, and you must tell us now that k is what? A constant. Always remember to tell us what k is. So then, we now plug in the values of x and y. It has been given in the question that x is what? 2 and y is 27. Can we plug in that values? The values? Okay, so we have 2, which as represents x, equals to 2 equals to k over square cube root of 27. So we have 27 here. Okay. So then we have 2 equals to k over, what is cube root of 27? Cube root of 27. So I want you to drop the answer in the comment section. Let me see. Do we know what cube root of 27 is? Yes. Okay. Let me see. Cube root of 27. Yes. Anyone? What is cube root of 27? Okay, I can see Diola. Who else? Okay, cube root of 27. Yes. Good. Cube root of 27. Cube root of 27. Good. Cube root of 27 is 3. So that's very good. Now you are doing fine. Cube root of 27. So once I ask for cube root of a number, so what I'm asking is, what are you going to multiply by itself 3 times that will give you what we have inside the roots? And that is 3. So put it together for yourself. That's very good of you. So this is 3. Okay, so you can cross multiply now because this is 2 over 1. So you have k equals to 2 times 3 and k equals to 6. All right, so we have this. Then to answer the first part of the question, because the question wants us to find the connecting formula. All right, so now you come here, this equation we have here. So this is what you are writing. So you just change the constants to what you have here. So we now write thus x equals to 6. Now we have replaced k with 6 over cube root of y is the connecting formula. Good. Do you get that now? All right, so we have gotten the connecting formula. It's as simple as what we have there. Okay, so now can we move on now? Now let's do the B part of the question. Now the question says find x when y is 125. Find x when y is 125. Now, we want to get the value of x. So let's plug in the value of y into this equation. So you have x equals to 6 over cube root of 125. Yes, so now I need you to tell me what is cube root of 125. So I want to begin to see our answer now. What is cube root of 125? Yes. Okay, I can see Shuko, I can see, yes, Riscott. Yes, okay, good. Good, good. Okay. All right, so that's very good of you. I can see 5, 5, 5. Everybody is saying 5. So that means that there's something about that 5. So 5 is the correct answer. So we all got that. So this is 5. Now, because cube root of 125, for those of you that did not get it, what we are asking now is that what are you going to multiply by itself 3 times? Because we have cube root now. That is going to give you 125. And that is what? 5. Okay, so now, therefore, x equals to, now 5 can go in 6 one time, so we have 1 left over 5. So this is going to be the answer to the problem. All right, so we have done with that with the question. So how do we award marks to this um, solution? So now for plugging in the value correctly, there will be a method mark, 1 for that. For getting the constant, we have A1. Now, for finding the connecting formula, because the question actually asks you to find the connecting formula, there will be an accuracy mark for that. Okay, so for plugging in the value of 125 into the connecting formula, we have M1, and then for getting the value of x to be one whole number 1 over 5, we have accuracy mark of 1. So now please, you have to be very careful when solving. Once you discover now that you can still simplify further, make sure you simplify. Don't stop here, because many students, they just stop here. Once you stop here, you will be losing points. So always try as much as possible to simplify to the last, because that sometimes now this will not, mark will not be awarded to this. All right. So just like what I just did now, no mark was awarded to this. So if it were to be a normal exam, so that means you'll be losing a point here. Okay, so always try as much as possible to simplify. So that's the answer to that problem. All right, so one more question under indirect variation. Okay, so now let's look at another problem. Okay, yes. Now I'm going to ask you this question before I move down to the next one, the next question. So I want you to quickly do this one for me. Do this for me. Find x when y equals to okay, let's see, 27. Okay, so now can you do that and tell me what you have using this connecting formula? Find x when y equals to 27. Yes. Now drop your answer if you have your answer. All right, drop it in the comment section. Let's see. Yes. Okay, since some are complaining they can't see the other side. Okay. Okay, I'll try and let me try and adjust that. I think it should be better this way now. Okay, good, good, good. All right, I think yes, we have 2. as the answer. Okay, let's see. Are you sure that is the correct answer? Now let's look at it together. Okay, now we have the connecting formula. This is the connecting formula. Now let's see, we have 6 over cube root of what? Of 27. And that is going to give you 6 over 3. And that is what? 2. So that means those of you that got 2, you are correct. So you can put your hands together for yourself. That's very good. All right, now let's move to the next one very fast. Okay, yes, this is another question. I want to believe you can hear me and you can all see the board. I've tried to adjust the board. Yes, can you all hear me? Can you see the board? Okay, can you all hear me? Can you see the board? Okay. Okay. All right. Okay. Okay. We can all see the board. Okay. All right. Now let's look at the next question. Now you are given that A is indirectly proportional to the square of B, and A is one whole number 5 over 4 when B is 1 over 3. Now find B when A is 9. So how do you do this problem? All right, let's start. Now we have A is indirectly. Now indirectly means inversely. Okay, so we have 1 over indirectly proportional to the square of B. Square of B is B squared. So we have square of B, B squared. Okay, I'm taking that again. A is indirectly. Indirectly means inverse, proportional to the square of B. So this is the square of B. Okay, and A is this, while B is this. Okay, A is 1 whole number 5 over 4 and B is 1 over 3. So now, but before then, let's change this to equation. It implies A equals to K over B squared, where K is a constant. All right. So here, now we can plug in the value of A and B. Now let's plug in the value of A. So A is 1 whole number 5 over 4 equals to K over, now B is 1 over 3 square. Okay, do you get that now? So now let's express this one in improper fraction. So that's 4 times 1, 4 plus 5. That's 9 over 4 equals to k divided by, so I'm writing it here now, divided by 1 over 3 square. Okay, can you see that now? So now this is 9 over 4 equals to k divided by 1 over 9. Now this is 1 over 3 times 1 over 3. That gives you 1 over 9. Okay, so now this is 9 over 4 equals to k times 9 over 1. All right. So once you change this to multiplication, so you find the reciprocal of what you have here. So here you can divide both sides by 9. So I will divide this by 9, this by 9. So once I divide this by 9, so now I have 9 here, I have 9 here. Okay, so 9 cancel 9. So 9 cancel 9. So I have 1 over 4 equals to k. So the proportionality constant is 1 over 4. So we can plug this into this equation here. So we have a equals to, now that's 1 over 4b squared. Okay, so look at k here. Now you can see that 1 is at the top, 4 is at the denominator. So that is one reason why when you substitute here, you make the 4 to go down and 1 stays at the top. Okay, so this is the connecting formula. All right, so now let's look at what the question wants us to do. The question asks us to find b when a is 9. You find b when a is 9. So now let's plug in the value of a. So we have 9 equals to 1 over 4b squared. Okay, so here you can cross multiply. So when you cross multiply, now this one is the same thing as 9 over 1. So when you use this to multiply this, you have what? You have 36. 36b squared equals to 1. Okay, this times this, that's 36b squared. 1 times 1, 1. So you divide both sides by 36. So you have b squared equals to 1 over 36. So when you divide both sides, now you find square root of both sides. So we have b equals to square root of 1 over 36. And therefore b equals to plus or minus 1 over 6. Okay, so that's going to be the answer to the problem. All right, so when you find square root of a number, you have two answers. So you have positive and negative parts. So that is the answer to the problem. All right, so I want to believe we all understand that. Okay, all right, so let's move on to the next question. So I'm going to employ you, if you're watching, make sure you give a thumb to the class if the class is impactful. And if you are just joining the class for the first time, ensure you subscribe to the channel. And don't forget to share this video with your friends. Okay, so now let's look at the next question here. Okay, I think maybe before I move to the next question, let's try this. Let's see what we have, what we're going to have. Let's quickly try this under inverse variation. Try this. This. inversely. Okay, now look at this question. If x varies inversely as y squared and x is 3 when y is 1, find x when y is 5. Okay, can we quickly do this one? Let's do it within 2 minutes and let's see what we can come up with. And let's drop our answer in the comment section. So I just give you 2 minutes to quickly attempt to this problem. Okay, now let's quickly do that. That's the question under inverse variation. Yes, let's see. Okay, someone have gotten the constants to be 3. Yes, okay. All right, so what is the value of x? So the question asks you to find x and not k. All right, that may be your k. That's a good one if that is your constant. Now go further and find the value of x. Okay, someone have dropped an answer. Okay, Nifemi, I can see that x is 3 over 25. Yes, any other person? Okay. Okay, this is Ellen. Okay. Okay. Yes, this Adeboye. This Bolaon. Yes. Okay, I can see Uba. Okay. Yes, I can see Rofiat. Yes. Okay. Okay, you have the connecting formula. Okay, who's dropping the that's familiar is dropping the connecting formula. Yes. Okay. All right. Okay. 3 over 5. 3 over 25. Okay, 3 over 25. Okay, I have I think I'm seeing 3 over 25, 3 over 25. Okay, let's see which one is the correct answer. So that we move on to the next thing. Okay, yeah. All right, I salute you. I can see that you are doing something. So now let's see what we have. Let's check whether what you have is correct. Okay, let's look at this. So we have x varies inversely as y squared. X varies inversely, that is 1 over y squared. That is what we have there, inversely as y squared. So that implies that x equals to k over y squared, where k is a constant. Okay, so now let's plug in the values of x and y. So we have x is 3. We have 3 equals to k over 1 square. Okay, so you have k equals to 3 times 1. K is 3. Good. So now the question asks you to find x when y is 5. So we need to get the connecting formula. So let's quickly do that. So you have x equals to 3 over y squared is the connecting formula. So now let's plug in the value of y. So we have x equals to 3 over 5 squared. So therefore, x equals to 3 over 25. So this is going to be the answer to the problem. So I can see that a lot of us got the answer. So if you have done it this way, let's see how the marks will be awarded. So for substituting correctly, we have M1. For getting k to the 3, A1. The connecting formula, this is the connecting formula, you have B1. and for substituting into the connecting formula M1 and for getting the answer A1. So 4 marks. So we have done it this way. That means we have gotten 4 marks. So no, 5 marks, sorry. So if you got 5 marks, so put it there, let me see what you score. So you know, if you don't substitute correctly, so you miss this one. If you did not substitute correctly, so if you do it exactly as what we have on the board, so let me see what you score. So mark yourself and let me see your score in the comment section. All right, now let's move down to the next thing. Why we do that? Exercise 5. Okay, let me see. Yes. How many of us got 5? Oh, okay. I can see good number of us. All right, that's good. That's good. Okay, now let's move down to the next question. Let's move down to the next question. This question is under joint variation. Let's see how do we solve this type of problem. Okay, now let's read. Now, y varies inversely as square of x and directly as the square of z. Now, if y is 12, x is 2, and z is 4, find the relationship connecting x, y, z, and find y when z is 6 and x is 4. So now, let's interpret this question. Now, x varies inversely. I start, x varies inversely as the square of x, inversely as the square of, and directly as the square of z. So that means I have z squared over x squared, okay? X squared. Hope you understand that. Now let's look at it again. Y varies inversely. That means we are talking about the reciprocal of the square of what? Of x. So the reciprocal, so we have 1 over x squared. Okay, so that means x squared comes down. So that's why we have it at the denominator. And directly as the square of z. So this is the square of z directly. So z is not indirect, so it's not coming down, so it's going to stay at the top. So that is what we have there. So this can be written as y varies, can write it this way, z over x squared, all squared. So you just factor out the square. Okay, so now you have, that implies that y equals to k z over x squared. Okay, so we can have it that way. All right, now let's plug in the values of y, z, and y and x. Okay, so now what do we have? Y is 12 equals to k times z is what? What is z? What's the value of z? Z is 4. We have 4 over x is what? X is 2 raised to the power of 2. Can you see that now? Okay, so now we now have 12 equals to k times, now 4 divided by 2, that's 2. 2 raised to the power of 2. And that's 12 equals to k times 4. 2 times 2 is 4. So you divide both sides by 4. You have 12 over 4 equals to k. So k equals to 4 goes in 12 is 3. Right? So that's what we have. So the question wants us to get the connecting formula. Okay, so we have thus. So I'm writing this out. K is changing. Okay, but don't forget we have to say k is a constant. It's very, very important. So don't let us forget that. So we have y equals to 3z over x squared is the relationship connecting x, y, and z. Okay. So now, can we move down to the next part of the question? Now, the question asks us to find y when z is 6 and the x is 4. Now, let's plug in the values of z and x. We have y equals to 3. Now, z is 6 and x is 4. Everything raised to the power of 2. So we have y equals to 3 times. Now, this is the same thing as 3 over 2 squared. Okay, so 2 goes here is 2, 2 goes here is 3. So we have 3 times 3 over 2 times 3 over 2. Okay, so and that gives us what? 3 times 3 times 3, that's 27 over 2 times 2, that is 4. So how many 4 are we going to see there? Okay, so that's what? 6 remaining 3 over 4. That's going to be 6 whole number 3 over 4. All right, so that's the answer to the problem. All right, so I want to believe we all understand the solution to that problem. So how do we award marks? The first thing, for writing, substituting the values of y and x, z. So we have m1. For getting the constant, we have a1. For the connecting formula, a1, substituting correctly, m1, and for getting the correct answer, we have a1. So that is the answer to the problem. So now let's look at another wonderful question under joint variation. Okay, so that's the next thing we are going to be looking at. So if you are just joining us, don't forget to give a thumb to the class, and don't forget to subscribe if you have not done that. And don't forget to also share this video with your friends. Okay, so let's look at the next question. Okay, yes, this is another wonderful question. All right, I want to believe every one of you is hearing me. You can hear me, and you can also, can we all hear? Okay, hope we can all see the board. Okay, yes, okay, okay. Yes, I want to know if you can hear me and you can also see the board. Okay, yes. Now let's move down. Let's move down to this question. Okay, so now let's look at the question. Now, if P varies jointly as Q and the square of R, find the percentage change in P if P is increased by 20% and R is increased by 50%, when P is 15 and Q is 3. R equals to 2 number 1 over 2. Find P when Q is 1 and R is 10. So how do we solve this problem? Now the first thing, let's look at the first phrase here. Now, if P varies jointly as Q and the square of R. Now, can we write that statement out? So the first statement is P varies jointly as what? As Q and R square. Okay, so and this turns to P equals to K Q R square, where K is a constant. Okay, I want to believe we all understand that. So I want us to be doing it step by step. Now let's move down here. If the percentage change in P, find the percentage change in P, in P, if Q is increased by 20%. Okay, so that means the value of P is increased by 20%. All right, so it means that we have a new P. Now, let's call that new P P1. The new P is when P is increased by what? Okay, sorry, that's Q. I want to say, so we have okay, so let's say Q. What is increased by 20%? That's Q. All right, so that means we have new Q will be what? That is going to be 120 over 100 of the original Q. Can you see that? Now, it has been increased by 20. So that means we are going to have 100 plus 20 over 100. You know, percentage is what? 100. You understand now? Okay, so this is what we have. So this is the new Q. Now, let's see. We are also told now that R is increased by 50%. So we have a new R. So let's call it R1. So it has been increased by 50%. So what will that one be? So that's going to be 150 over 100. So that's 150 over 100 R. So this is the new R. Okay, so I have to look at what I have here now. Okay, so R1 square, okay, R1 square is the same thing as, now you can reduce this will cancel this, and the 5 goes here is 3, 5 goes here is 2. So that means we'll have, now R squared now is going to be 3 over 2 R squared. So this is what we have. I hope you understand that. R1 is 150 over 100 R. Okay, so I just simplified this. So this is 3 over 2 R. So when you square both sides now, this is what you're going to have. Okay, so that is the same thing as what? 9 over 4 R squared. Okay, that is R1 squared. Okay, so the next thing now is to get, because we actually want to know the increment in P, the increment in P when Q is increased by 20% and R is increased by 50%. Okay, so you now have P1, okay, P1, this is the new P, so P1 equals to, now we are making use of this, equals to K Q1, you know, Q1 and the R1. So that is what we have. So that means P1 is the same thing as K times, what is Q1? We have Q1 to be this. So you can reduce this. This is the same thing as 0 cancels 0. So, and let's say 2 goes here is 5. 2 goes here is 6. So we have 6 over 5Q. All right, so that's going to be 6 over 5Q. All right, so now let's look at R1. R1, all right, this one's supposed to have square. Okay, so there should be a square here. So R1 square is this. So you have 9 over 4 R squared. Okay, so now let's tidy up this. We have P1 equals to, now let's tidy up this. Now let's multiply the numbers together. Or before we do that, we can simplify. 2 goes here, 2 goes in 4 is 2. I say 2 goes here is 2, 2 goes here is 3. Okay, so let's say 3 times 7, that's 27. So we have 27 over, now 5 times 2, that's 10. 27 over 10. Okay, so we have KQR squared. So that's what we have. Hope you get that. Good. So now we now have P1 equals to, now when you look at this, this is the same thing as what we have here. Right, so that's the same thing as P. So that means I can replace KQR squared with P. So this turns to 27 over 10 p. That is what we have, because this is actually p here. You can see now. So we have p. So what's the next thing to do? Now, because I want to know the percentage, so I will multiply the numerator and denominator by 10. So that implies that P1 is equals to 270 over 100p. Okay, so now to not get the percentage in increment or change in percentage of p. Now change the percentage, you just subtract 100 from 270. So now the percentage increment now is going to be so the percentage change in p, percentage change in p, percentage change in p will be 170%. So this is going to be the increment, and that's what the question is asking for. Okay, so just subtract 100 from 270. So this is the increment. All right. Okay, so that's a very interesting question. Okay, so now we can move on with the question. Now the question now go further, that when P is 15 and Q is 3 and R is 2.5, find P when Q is 1 and R is 10. So what we just need to do here now is let's plug in these values into the connecting formulas that we have here so that we get the proportionality constant. So let's do that. Okay. So we have P equals to, okay, so P has been given. What is the value of P? That's 15. So just plug in the value of 15. P equals to K times Q. What is Q? 3. 3 times, what's R? R is 5 over 2. This is the same thing as 5 over 2. We have 5 over 2 squared. Okay, so now we have 15 equals to K times 3 times 25 over 4. Because 5 times 5 is 25, 2 times 2 is 4. Okay, so here, let's divide both sides by 3. So when you divide both sides by 3, 3 goes here 1, 3 goes here is 5. I can divide both sides by 5 as well. 5 goes here 1, 5 goes here is 5. So that means that I'll be having 1 equals to, now K times 5, we have 5K over 4. So you can cross multiply. So if you cross multiply, that implies that 5K equals to what? Equals to 4. So you can get your proportionality constant now. So now K equals to 4 over 5. That's what we are. So when you divide both sides by 5, you have K equals to. So now let's get the connecting formula. The connecting formula, now what's the connecting formula? So just come here and plug in the value of K. So you have connecting formula, we have P equals to 4QR squared over 5. So that is what we have as the connecting formula. You can see that. So just plug in the value of K into this. So you have this. Okay, so now the last phase of the question asks you to find P when Q is 1 and R is 10. Okay, so so let's plug in the value of Q and R. R is 10 and Q is 1. So let's plug in that. So that means P will be equals to 4 times 1 times 10 raised to the power of 2 over 5. Okay, so that is going to be, and let's say this is 4 times 100, because this is 10 times 10, that's 100, so everything over 5. So 5 goes here 1, 5 goes here is 20. Okay, so 4 times 20, that gives you 80. So we have P equals to 80. So this is going to be the answer to the problem. All right. So I want to believe we all understand this question. So, but I have a feeling that probably maybe some of us may not may find it very difficult. But then we can always go through the video again and see how I solve this problem. So there's no big deal about it. Just look at the procedure. All right. So there are some questions sometimes may require a lot of attention. So once you give you your attention, you should be able to get the question. So there's no big deal about it. Okay. So I'm going to be stopping here today. So I want to appreciate everyone that watched. So thank you very much. I want to appeal to you. So if you are watching for the first time, ensure you subscribe and also share this video with your friends. Let many students get to know about this video. Let them come. Let us have a nice and let's have fun with mathematics. Okay. So give a thumb to the class and have a wonderful time. Thank you very much for watching. Bye bye.